Hi, my name is Aiden Beheimer, and for my experiment, I am doing throwing a football. I am doing this because I've been playing football for as long as I can remember, and it means so much to me and my family. And I thought it'd be really interesting to learn some of the physics and science behind what goes into football and throwing it, and kind of how it works. The reason this interested me is because football has been pretty much my entire life, and going into this with a science experiment, I think would be cool and a lot funner for me rather than doing something simple like a ball, like a normal ball or a cup or something similar to that. My example video is me throwing an NFL sized ball across my yard with my dad filming it. For Unit 1, the very first pieces of information that I needed was to find the mass of the ball, which is the resistance of a body of matter offers to change a speed or position. The second piece is the distance the ball traveled, which is how far the object went. The third and final piece is time, which is how long the object took from when it was thrown to when it hit the ground. The first thing I needed was distance. I measured with the tape measure about 39 feet, which converted into about 11.89 meters. Then I was able to look up what the weight of a standard NFL-sized ball was, and from there I got 0.43 kilograms. Finally, I had my dad time me from when the ball left my hands to the time the ball hit the ground, and that number was about 1.55 seconds. Once I had the distance and the time, I could then find the velocity. To find that, I used the equation velocity equals distance divided by time. So I did 11.89, which was my distance, and divided that by 1.55, which was my time, and got 7.67 meters per second as my total velocity. Once I had my velocity, I could then find my acceleration, which is the rate in which the velocity changes. The equation for acceleration is the final velocity minus the initial velocity divided by the time. So in this case, I did 7.67 minus 0 and took that and divided it by 1.55, and I got a final acceleration of 4.95 meters per second squared. For Unit 2, the first part of the information I needed was the Newton's first law, which states that an object in motion will stay in motion unless acted on by an outside force, as well as stating that an object in rest will stay in rest unless acted on by an outside force. This relates to throwing a football because when you throw it, the only thing that brings it down is Earth's gravity and the friction. Newton's second law states that the amount of force applied causes it to accelerate from 0 miles per hour to any speed. The force action on the football is the person throwing the ball, and the force that is needed to throw the ball is dependent on the mass of the ball and how far you need the ball to go. The free body diagram I have shows that 1, Earth's gravity is the only thing that brings it down, and 2, the force of the air resistance goes against the applied force by the person throwing it. The next piece of information I found was momentum, which is basically the quantity of motion that an object has. To find momentum, you have to use the equation momentum equals mass times velocity, which is the mass was 0.43 kilograms and the velocity was 7.67 meters per second. 7.67 times 0.43, which gives us a momentum of about 3.3 kilograms per meters per second. The mass was 0.43 kilograms, and I found that out by looking up the standard size of an NFL ball since they are all the same. After finding the force acting on an object due to gravity, the gravity in Earth is 9.8 meters per second. The equation for weight is weight equals mass times gravity. So my mass was 0.43 kilograms and the gravity was 9.8. So 9.8 times 0.3 gives us a weight of 4.21 newtons. The difference between mass and weight is that mass is a measure of the amount of matter in a body, while weight is a force acting on an object due to gravity. The mass will always be the same no matter where you go, but the weight will differ in different places. For Unit 3, the first part of this unit was work. Work is a measure of energy that occurs when an object is moved over a distance. To find work, I need the force of the object and then also the displacement or the distance. The equation for work is W equals FD, or weight equals force times displacement. So for football, it would be 4.21 times 11.29, which gives us 50.06 joules for the work. The next one is power of the throwing the ball. Power is pretty much the rate at which work is done. To find power, you need to divide the time from the work. So in this case, I did 50.06 divided by 1.55, and I got 32.2 watts as my final answer for the power. The next one is my kinetic energy, or KE. Kinetic energy is the energy an object has due to its motion. The equation for KE is KE equals 1/2 of mv squared. So I took half of my mass and squared my velocity, which was 7.67 meters per second, and I multiplied them to get a total of 12.65 joules for my final kinetic energy. The final part of this unit was to find the greatest potential energy, or the GPE. GPE is the potential energy a massive object has in relation to another massive object due to gravity. To find this, you need the gravity, which is 9.8 newtons, mass, which is 0.43 kilograms, and height, which is 5.21 meters. The equation for greatest potential energy is GPE equals mgh, or GPE equals mass times gravity times height. So I did 0.43 times 5.21 times 9.8, and I got 21.95 joules as my greatest potential energy. In conclusion, this experiment really helped me understand the science and numbers that goes into the simplest things, such as throwing a football. I think that this could be very useful to quarterbacks, especially who need to have their timing and power down perfect to make good and smart throws and hopefully make it into college and the NFL. And I'm sure, especially in the college and NFL, quarterbacks know some of this information. This could be helpful to other sports as well that have the same concept as throwing a baseball, such as basketball or baseball. It really helped me understand everything we did and how it really matters in real-life situations, and definitely helped with my interest in this project, since sometimes I'm not the most interested in some science projects, but adding the football aspect into it really helped. Thank you.